put this thing on. Here we go. How are you guys going? Oh, it's great to see such a turnout. It's been a while since we've had this many people in one room, so thanks for everyone for coming. Looking forward to an exciting year. So I wanted to start off with kind of this example you can see up here. And it's kind of very simple, but it illustrates kind of what I like about data science. And so I don't know if any of you know anything about diamonds and how they are appraised. But essentially, if you find a diamond, you go to someone who appraises it and they say, okay, what are the kind of the value of it? And one of those values is called the carat. So it's essentially the weight. And on the left, what we're going to do is we're going to look at a bunch of different appraisers and look at a histogram, which describes kind of the carat, the frequency of different carat levels. And so you can see on the left, you've got the carat on the x-axis and sort of the number of diamonds that they looked at, and the carat and the number that fell into those different bins. And the first thing to ask yourself is, well, okay, obviously we know that the taller bars show more frequent values, but firstly, does this kind of fit with your expectation of what it should be? So for me, it does, sort of, because we know that as we move to the right, higher carat is more valuable. We should expect fewer of them, right? More rare. But then one thing that's kind of weird here is that, I would expect it to be some sort of exponential distribution. So essentially just tapering off slowly like that, you'd expect. But it's kind of weird, you get this jagged pattern. And then what we do on the left here is we say, okay, well, what if we reduce the bin size? So, what we're going to do is make it more defined. And you can see what's happening here is that we're getting like dips towards the whole numbers. And maybe some of you can try and figure out what's going on here, but I'll give you some time to look at it. But what's happening is that appraisers are going to diamonds. And if it's, say, a carat of 0.9, they're just going to round it up to 1. So that's why you're getting, like, at whole numbers, massive spikes of carats. And so this is kind of like a very simple example, but it illustrates something that I really like about data science, which is, you find something that's not immediately obvious, and then you look into the data and you can extract patterns and draw insight. So I hope that kind of motivating example for why I like data science is useful to you. And then, Lorenzo, do you want to talk about what is data science? Sorry, here you go.
Yeah, it's going to be a bit of switching the microphone. So data science is actually kind of an umbrella term. Okay, so there are many things that go into data science. There's surely a lot of computing, because that's where, that's kind of what enables us to do data science. And that's why kind of this subject started getting on just in the last 20, 30 years, because computers became more and more powerful. There is a lot of maths and statistics, and there is, of course, knowing the subject. Okay, so if I'm going to use data science to analyze biological problems, then I need, of course, to know what these problems are. So it's kind of all this intersection of all these things. Now, I wrote a couple of, I copied a couple of words on the slide. So it's surely multidisciplinary. Surely you try and analyze data to get some insight. For instance, I don't know, internet, people do that to try and discover new particles or things like that. Then it is descriptive. It provides descriptive analytics, predictive analytics, prescriptive analytics. Now, what does this mean? So descriptive means that you can use the tools that are covered by this subject to kind of describe some data. This data can help you predict things about the future. For instance, what's the chance that this football team is going to win a certain match? And then it offers prescriptive analytics. Now, this is probably one of the most important things, right? Because what it means is that it tells you what you should do. And that's why data are so important for, especially for big companies. They exploit them a lot because they kind of tell us what their next steps should be. I know, should we try and make this new product? Maybe, given our data, we believe that people will like it. So that's fantastic. And that really gives an extra gear to people who have data and know how to exploit them, compared to maybe another company that doesn't have all that knowledge about the market, for instance. And yeah, now I keep the microphone back.
So the key thing that I have to highlight here is that data science is really extremely diverse. And I'm sure a lot of you are aware of this fact. So these kind of like 3 examples are different, just examples of data science. So the one on the right is a basic Sankey diagram, which demonstrates how harsh online dating can be with, if you use Tinder, the swipes are on the left, and then right down here, this tiny little thing right here is kind of the success rate of those swipes. So that's, one element of data science. That's just, a high level overview of things. And then, another element of data science is shown up there is the clustering algorithm. So that's probably more on the modeling side. And that's used for fraud detection. And then, I couldn't give this lecture without mentioning the AlphaGo, which I'm sure many of you are aware of, but essentially they trained using reinforcement learning, so very complicated methods, they trained the computer to be a professional Go player. So all of these things are examples of data science, but you can see how varied the field is. So it's often helpful for you guys to try and categorize the different areas of data science. Now, I understand that this probably is fairly crude, but I like to see data science with these 3 different fields. So you've got data analysts, and these are the people that sit at a high level that they look at bar charts and graph charts, and they use their business understanding and high level things to convey information and to drive those insights and do that prescriptive decision making that Lorenzo was talking about. And then you have data engineers that really sit kind of at the back end. They're developing all the warehouse and all the database structures, so they're far more distant from the high level explanations. And then finally you have data scientists. So I don't like the way this chart's put out because I kind of see it as being data analyst, data scientist, data engineer, because then it makes a bit more sense. That is incredibly frustrating. But I hope that's a kind of useful way to look at it, because each of those different areas engenders a different skill set. And so when you go to do your job applications, maybe for many of you it'll be a long time from now, you can think about which of those areas you'd like to fit in if you do pursue this route. And you should definitely pursue the route, because that doesn't need me to tell you that data science has just exploded in the last 5 to 6 years. So it's been incredible growth, and we're expecting this sort of growth in the market, well until 2030. In fact, it's probably just endless. As we get stronger computers, we have more and more data, and we have more and more data capabilities, and we need more people to work on that. And so, even I think this is LinkedIn, they found that, the 3rd most demanded job in the US job market is data scientist. So, Lorenzo's going to give you an example here.
Okay, so just to give a more concrete example, what kind of are the steps they need to do, for instance, a machine learning project. So the first thing you need is a problem, right? So what are you trying to do? So let's say our problem is write some software, some kind of computer program that, given some data, it tells me what the next football match, what team is going to win the next football match, right? So what kind of data could I need? I could need, for instance, what team is playing in home, how did both teams perform previously? I don't know, I need disqualified players. Maybe one team is playing with 10 players, the other one with 11. That could have an impact, right? So we could think about all the type of data that could be relevant. Then we need to go and get this data somewhere. So maybe we need to do some web scraping. That means that you write a piece of code that takes information from a website and it loads them to a file on your computer, for instance. Then you need to see, are all this data relevant? Surely I would think that seeing the performance of the team in the previous matches is a relevant piece of data. I don't know, is the color of the ball relevant? Probably not. So sometimes things are in a gray area, so you kind of need to understand what you want to keep and what you want to throw away. And then you need to be sure that the data are okay. Maybe the data are missing some bits. You don't always get all the data tiny in your column and all the rows filled. Maybe one row is missing. How are you going to deal with that? Then once you figure your data and you give a look to them, you know what they're telling you. you need to try and write a model. What is a model? A model is just a function, okay? So you put inside this function, you plug all the data, and it spits out what the winning team is, right? So there are several ways to do these models. I know neural networks are quite popular, but linear regression, which is just a line, is already machine learning. And then you need to check, is my model working fine? And you need to show that model is actually useful to maybe make bets, and so winning money or stuff like that. And last thing, okay, maybe not in this case because you want to keep the money just for yourself, but usually you would like to communicate what you did to other people. Maybe people are going to be not experts in the field, so you need to be clear and be able to speak language that everyone can understand. So these are kind of the steps of I would say a project. So you have your problem, you collect your data, you check that the data okay, do I need something else, are they enough, and stuff like that. Then you define your model, you train your model, which means you try to find that function that actually does the job that you're looking for. You check how well your function is working. Was it worth the time you put into it, for instance? And then you want to communicate the results. Now, this is true for a small project. If you are in a big company, then you have a lot more stuff that you need to think about, all the infrastructure. How do I make this new thing I created available to other people? But we're gonna kind of ignore all that part. What was that? I don't know.
Yeah. This is just a separate note because while we have you all here, just wanted to kind of illustrate what's going to be happening through the term before everyone gets a bit tired through the session. So firstly, you're in the lectures right now, and we'll be operating these bi-weekly every Tuesday. And so what we're going to do is just slowly work our way from the basics of Python through to more advanced topics in machine learning and data science in general. And then you'll also have the workshop. So following these lectures bi-weekly, each Saturday we'll try to run a workshop where you can actually get more hands-on experience. And then if you're interested, and for those of you that are feeling a bit more comfortable with the topics, you can try and apply to these advanced projects. Now, we'll send out kind of emails about this, but essentially, we've got really good big advanced projects that are in the pipeline. So, for example, working with the government, working on a satellite project, and then on an autonomous vehicle project. So if any of those are things that are interesting for you, check them out and maybe sign up. And then finally, we're going to be having recruitment talks. So that's also in the works as well. We'll have them, this will all be detailed in emails, but just so you guys are aware of what's happening. And kind of the big thing for us, the piece of resistance, is the hackathon. So the hackathon will be in February. Now, the idea here is to kind of, go from working you up towards that hackathon. So for those of you that are, not such a high level currently, that's all right, because in February we'll have a hackathon, and until then we'll try and help you develop your skills. And so I hope that kind of gives you an overview of what we'll be doing this year. But why don't we get on to actual implementation?
All right. So this is going to be the start of the workshop. If you have a computer, you will be able to follow along. So there's going to be a QR code, and you can scan it and get to a Jupyter notebook that we prepared. So first, I'd like to ask you questions. So let's say, yeah.
There's no questions on the team.
Amazing. Yes, let's answer these ones first.
How do you know trivial parts of the data aren't still important?
So,
for example, causation and correlation.
How do you know trivial parts of the data aren't still important, e.g. causation and correlation? Yes, that's a very good question. A question I am personally not sure. Yes, because I'm kind of a student as well, so no, unfortunately I don't know everything. Do you have an answer?
You can give this.
Okay. So would visualization of the data be included under communication of results? I think so. Like if you have something important that you want to Like it kind of depends on what it is, right? So if it's something relevant, a pattern that you found in the data that you're exploiting, and so you want to publish your result, and you want to show this new thing that you actually found, then it makes sense to put it in potential paper or website that you're going on to put on. So I think it's a case-by-case situation. Yes, keep posting questions if you have them, and if I know how to answer them, I'll be happy to answer them. So let's do it now. Who has already previous experience in programming? Raise a hand. Oh, that's a lot of people. Who has experience in Python? That's still a lot of people. Experience in TensorFlow. Experts in TensorFlow. Amazing. Okay, but it's cool. Many people know. So, okay, this is going to be a bit basics for like 99% of the people in this room, because it was probably targeted to a different audience. But I'm glad I'm gonna stay for the pizzas at least. Okay, so what is Python? Python is a programming language. It is easy to learn. Well, I wouldn't say that. I would say it's kind of easier to learn, right? It's still hard. But it's quite powerful, right? So you can get a lot with few lines of code. So it's really worth learning it. It is an interpreted language. What does it mean? It means that your piece of code of Python gets fed to another program that is called Python interpreter. Okay, so line by line, your code is fed into this program, and the program executes the command. Okay, it forces you to be tidy. Kind of tries to ask you to be tidy. You can be untidy. So it doesn't use curly brackets. It uses indentation instead. So here we have two examples. This is a Python syntax. This is a C syntax. As you see, C uses these curly brackets to wrap the for loop, whereas Python just uses colons and the command, which is spaced by one tab. Okay, so this kind of releases some of the extra things that you should write in the code. Yes. So we're going to use libraries. So what are libraries? Writing code is long. Okay, so imagine you want to write the code just to draw a plot. How would you start? You will have to look, how do I make a white patch on my screen? How do I draw straight lines on that white patch? So it seems like a lot of work. So what we usually do is using pieces of code written by other people. These pieces of code are called libraries, and most of the important libraries are published on this thing on the left that is called Python Package Index. They're there, and you can install them super easily on your computer with one line of running one line in your terminal. So that's another reason why Python is very good, because you install things that other people did very quickly and with almost no effort. In particular, we're going to deal. Any question? Okay, we're going to kind of work with these libraries. At least these were the ones that came to my mind. There might be other surprises. So we have TensorFlow that is used for machine learning. We have Matplotlib here that is used to make pretty plots. We have SciPy and NumPy. Now, is there a difference between these two? Yes. So SciPy is kind of an extension of NumPy. So you can do whatever you can do with NumPy, you can do it with SciPy. SciPy kind of offers some extra features, some extra cool functions that you might want to use. There is Pandas that's used to read data for Excel files. You can read them. I'm not gonna say easily, but you can read them with Pandas. And then we have PyTorch. PyTorch is used for machine learning as well. PyTorch, so TensorFlow was developed by Google and it's open source. If I'm not wrong, PyTorch is developed by Facebook and is still open source. I underlined the libraries we're going to work with today. So that is going to be TensorFlow, NumPy, and actually not Matplotlib, because we're going to work with Matplotlib on Saturday, when we're going to have the second piece of the workshop. So these are the things that we are going to introduce. The basics of Python, TensorFlow, and Tensors. So this is going to happen today. And on Saturday, we're going to work on how to import data into your Python program and how to plot them in a nice way. So in particular, this is very, very important, plotting things, because our brain works very well with images. And so if you want to communicate something to a person, it's easier to show them a plot than to show them a table or to show them a piece of text describing what you want to say. Okay, let's get started. So we're going to work on Google Collab. And if you follow the QR code, you will get to folder on Google. Hopefully, you don't have the editing permissions, because that would be messy. But you should be able to see two files. One is called lecture empty. The other one is called lecture full. So what we're going to do is kind of go through the main functionalities of Python, and I'm going to be writing on the lecture empty, okay, file. But what we're going to write is basically all the stuff that is contained in lecture full. Okay, so that's kind of lecture full contains all the things that have been already written, and we're going to work on the other one. So if you want to work beside me, you can probably copy paste lecture empty file on your Google Drive. What is Google Collab? So Google Collab is basically a way of coding on the browser. Okay, it's a service offered by Google, and we prefer using that so that you don't have to install all the things on your computer now. If you want to do it, you're more than welcome, but we just thought it would be smoother to do it that way. Now at this point, I will pause like 1-2 minutes to give you time to open things. And if you have any technical issues, feel free to ask us, raise your hand, and someone will come. Can you scan the code, for instance? Yes, no? Yes. Some people, yes. Is everyone okay? In Teams, for instance? I'm gonna text it. Okay, and okay, start. Okay, someone send me the link, please. I'm gonna send the link. So I'm going to send the link in the Teams chat. I didn't send it. Just 1 second. Need to get that. All right. Josh, are you in Teams? Are you still getting for forever? Another Josh. Now all good. Ooh, amazing. Okay. So I think we're ready to start. So I'm going to move this thing here. Full screen. Full screen. Okay. How many people worked with a Jupyter notebook before? Raise your hand. Okay, it's like, why am I here? So for the few people who don't know how it works, so you can put pieces of text and pieces of code. Okay, adding a new piece is very easy. So I go on this section. So the sections are these things which have a square around it. And then you can go beneath it and add code or add text. All right. So I'm going to write in this piece of code. The piece of code is gray. Gray. Text is not gray. And we're going to start by defining our first ever variable. So I'm going to call it num, and I'm going to give it a value of 42. So what did I just do? I create a new variable. I call it num. The equal sign is assigning value of 42 to the variable num. And this way, I'm basically storing this number into the memory of the computer. Okay. And once I have that, I can use it to do other things. For instance, I can print this number. I can run the code by pressing Shift Enter. So if you try that, you should be able now to run your cell. Amazing. I can also write something else. So for instance, I can write a piece of text. A piece of text is written by putting 2 quotation marks. So you wrap the piece of text by quotation marks. Answer universe is, let's say, to the question, big question. Okay, so now I see the first thing I read here in the output is 42. The second thing I read is this one. The answer to the big question is. So the print function is basically printing things on my screen. And I can also add a number to the text I'm printing just by putting a comma after the string and writing it num, which is the variable I created previously. So you see, Google automatically tells me that num is an integer. We don't know what's an integer yet. And okay, that's cool. I can make then many variables. Num1 is going to be 5. Num2 is going to be 44.8, for instance, right? And I can say the other variable is equal to cat. All these things are good in Python. And in Python, as opposite to other programming languages, you don't have to specify the type. So what is the type? So 5 is obviously different from cat, right? One is a number, the other is not. However, turns out that 5 is also integer. It's also different from 44.8. How do I do it? How do I check that? I can write the type. I can print the type of the variable. So I'm going to write print type num1. I'm going to copy this line, and I'm going to write num. And I'm going to write other variables. So what we're going to get is that num1 is an integer. Int stands for integer, and we all agree on that. Num, which is now equal to 44.8, is a float. So a float is basically a not integer number, okay? And it's not integer because we put a dot in here. Lastly, other variable they're created and assigned to each value of cat is a string, str. Okay. Amazing. Let me check the went through everything. Yes. So what can we do? What can we do with numbers? So we can add numbers. So for instance, if I c is equal to 4 plus 5, and I can print c, right? So I read here 4 plus 9 is indeed equal to 4 plus 5 is indeed equal to 9. However, instead of numbers, I can also put variables inside. So c is equal to num1 plus num. Now, the value we're going to get is, unsurprisingly, 44.8 plus 5, which makes sense, right? So we could also write what the type of C is. So the type of C is, and we're going to write type C. So we see that by summing an integer with a floating number, we get another number which is equal to 49.8, and the type is float. So this is also another thing which is quite cool about Python. Okay, basically you can add things together, and it's gonna choose what's the best type to assign it to the answer. Okay, so let's see how to make a function. So functions are pieces of code that we write so that we avoid repeating our code over and over and over. So let's say that we have a line, an equation for a line, which is y is equal to 3x plus 5. Okay, we want to evaluate this line for these points: -1, 2, 5, and 7. So one way of doing this could be x1 is equal to -1, and then I could say y1 is equal to 3 times x1 plus 5, right? And I could do that for all my 5 points. So next would be x2 is equal to blah, blah, blah. So this is kind of longer. We don't want to spend all this time writing all these things. So what I can do is writing up functions. This function, I'm going to call it my line. I'm going to put as input the value of x, and this function is going to spit out the value of y. So we do that this way. We write def, the name of the function, my line. And now I need to put in these brackets, I need to put the argument of my function. So I can call it whatever I want. So I could call it I could call it j. I'm just going to call it x, because I don't know, it's what we wrote earlier. And then I write a colon and new line. And then I'm going to write y is equal to 3 times x plus 5. I'm going to stop here and try this. So x1 is equal to -1, we said that. And y1 is equal to my line. My line of x1. Now, what answer do you think we're going to get? So raise your hand for 2. Yes. Yes. That's the thing. We're not going to get the right answer. So if I try to do print y1, we won't get what we'd like to get, right? Which is again +2. We're going to get none. Okay. Why none? Because we didn't tell the function what we want to get out of it, right? So I could also assign a new variable inside the function. So cat is equal to cat, right? So do I want to get the y? Do I want to get the cat? We don't know. In order to make it very explicit, we need to write return y. Okay, so return y is basically creating this arrow here. So when I call the function now is going to spit something out of it. And now probably it should work. Yes, indeed, we get that y1 is equal to 2, which makes sense. You know, now I can keep doing print my line of 2 and so on. And as you can see, I'm already saving a lot of code. Boom, all our values. Okay, that's cool. But how do we write, for instance, a cosine, right? So let's say we have an angle, which is equal to 3.14, for instance. We want to find the cos angle, right? How do we do that? We can't unless we find a way of approximating the cosine. What we do is using some other people's code. In particular, we're going to use one of the libraries that we saw before. That is called NumPy. So we're going to do import NumPy, and then here I'm going to say that cos angle is equal to NumPy dot cos, and inside I'm going to put the angle. So NumPy is the library, and the library contains a lot of functions. Okay, in order to choose what function I want, I need to write a dot in here after the name of the library, and write the function that I need. So I'm going to run this, and nothing happened because I'm not printing the values, right? So I'm going to do print cosine of 3.14 is cos angle, and it's quite close to -1. So this is the angle here is expressed in radians, not degrees. Okay, so that would be kind of equal to 180 degrees. This angle here, kind of 180 degrees. All right, so NumPy is kind of a long word. I get very tired of writing NumPy all the time. So what I'm going to do is import NumPy as NP. So as NP means that now instead of writing NumPy, I can just write whatever I write after as. So I could now say chicken, and then I would call the library using chicken. But NumPy is shorter than chicken, so we're going to use that. So NumPy dot cos angle, and you see that we get the same answer. Now let's see another data type. So we saw integers, we saw floating things, we saw characters. Another important thing that we need to use are arrays. So an array is just many numbers put together, right? So my array is equal to NumPy dot array, and here I'm going to put many numbers. Okay, so for instance 1, 2, 3, 4, 5. This is going to give me an error because that's not how you do an array of these 5 numbers. You need to put some square brackets around this. Okay, and now what I can do is I can print this array and see how it looks like. No surprise. Now, some other things that we need to be able to do is, for instance, how do I print the third, the fourth, or any element of this array? So the syntax to do that is this one: print my array, and I open some square brackets, and here I'm going to write the index. So these numbers are in this. So the index for these numbers work this way. Yes. Beautiful question. So let's see that. So this is my list, okay, which is 3, 4, 5. Hello. Hello. 4.8, and so on, right? So this is a list. I can run my piece of code, and Python is giving me an error, but not because of that. It's giving me an error because of this. Okay, so that is perfectly fine. I can put a list and I can throw everything inside it. Numbers, pieces of strings, and so on. Moreover, let's try to see what happens when I sum 2 lists together. What does it mean to sum 2 lists, right? It makes sense to sum 2 numbers, but how can I sum 2 lists? So let's do that. Print my list plus my list. So what happens is that I get my list, all the elements in my list copied twice. Okay. Indeed, I can also perform multiplications on the list. For instance, my list times 3. What I get is even more of the elements I put in the list. So it seems like they're not the best tools to use to do maths. Okay. So for instance, if I have a vector that I need to use, if maybe I have two vectors, like one is equal to 1, 1, 2, another vector that is equal to 2, 3, 2, 1. One of the things I would like to do is, for instance, multiply these two vectors together. So print that 1 times 2. Okay, well, I cannot do that, so I can sum them together. And this is what I get. Okay, I get even a bigger list. So 112 is the stuff that was in the first vector. 321 is the stuff that was in the second vector. So we don't use lists usually in doing mathematical things because they don't behave as we would like to. Arrays are kind of a type of spicy lists, and as we are going to see now, we can do cooler things with arrays. So for instance, let's take my array, and my array we're going to print it is the one down here. What happens if we multiply my array by 5? I'm just going to get all the numbers. Yes, amazing. So no, they actually work like if they were vectors. We multiply every element of my array by 5. Just one thing, you should need to be careful to one thing. So my array 2 is equal to numpy.array. Since I don't know. 1, 2, 2, 1, 4. Okay, when we multiply two arrays together, it is element-wise multiplication. Okay, so the first, let's do it. So print my array times my array 2. So the answer we're going to get is 1, 4, 6, 4, 20. And if we look here, the 1 comes from 1 times 1, 2 times 2 is 4, 3 times 2 is 6, 4 times 1 is 4, then we get 20. So we get element-wise multiplication. Some people maybe know that when you multiply two vectors, usually what in math, so what you do is basically you take the sum of all these elements into this thing, right? Because you multiply two vectors and you get a number out of it, not another vector. But anyways, that's how it works. Another question on this part? No. So loops. We write loops to save code. Okay. So let's say that we have our usual function that we had before, and yes, we have two types of loops in Python: while loop and for loop. So a while loop keeps running the code that you put inside the while loop until as long as a condition is met. We're going to give an example of that. A for loop runs a piece of code for all the items of a list that you're providing. Now let's see it more in detail. So let's say that we want to let's say that we want to find okay, we have our function here, right? Let's say that we just plug into this function integer values. So our question is, what's the value of the function that is just less than 100? Okay, not 100, no more than that. So one way we can do that is that we can start with our random guess. So for instance, x is equal to 0, could be like that, right? And then we write like this: while my line of x is less than 100, What? While I'm not sure. I forgot. Yes, for instance, print x. So let's run it. Ah, okay. Yeah. Oh my gosh, I broke everything. Okay. Yes. So I'm going to write x is equal to x plus 1. Okay, that was better. So this is what's happening. Okay. So x is equal to 0 here. So we said that the program gets fed line by line into the Python interpreter, right? So the Python interpreter reads this. Okay, that's cool. X is equal to 0. Then it checks. Is it true that my line of 0 is less than 100? Well, if I plug 0 here, I get plus 5. So this is true. So it keeps running the code. This thing, what it does is it kind of you may think, well, this makes no sense, right? X is equal to x plus 1. It's not true. Well, it is true in computing. So this means that you take x, you add 1 to x, and then you plug that value back into x. Okay, this thing is used a lot. So what we're doing now is basically we take x, which is 0, we add 1, so we get 1, and we put it into x. Then we print the value of x, and once the code goes here, it goes back to the beginning, to the while. We check that the condition is still satisfied, and it is still satisfied, and it keeps running this code until something happens. For instance, when x is equal to 32, then my line of 32 is going to be 96 plus 5, which is 101. So 101 is indeed greater than 100. So that's where the code is going to stop. So that's why the last value is 32. Now, for loops are arguably more useful in many cases. So let's say that I want to print the number from 1 to 10. I don't have to do this, right? I print 1, print 2, print 4, because that again takes a lot of time. What I can do is this one. For e in range 11, actually 111, colon print I. Okay, this is actually doing the job. So what is happening here? Range 111 is basically, it's a shortcut of making a list of numbers that go from 1 to 10. So the way you should read it is that is this way. So this notation means that you're taking the first number that you give, and then you're giving the other edge, where you want to stop this kind of pre-made default list, and you're going to stop it at 11 excluded. That's why we have a bracket, a normal bracket here. So we start from the value which is 1, and we don't get to 11, we stop at 10. So this is what we get, and that's right. So I have the feeling that all this was kind of not helpful to those that didn't know Python, and probably boring to those who knew Python. But I hope it's gonna be a bit of revision and have kind of knowing what are the things that we're going to use. Now, let's see what tensors are in this last few minutes. So a tensor is nothing but a table, okay? So a rank 0 tensor is just a number. What's the rank of a tensor? We're going to find out. A rank 1 tensor is a vector. A rank 2 tensor is a matrix. Okay. So the idea is that the rank tells you how many dimensions your table spans. Okay. A rank 3 tensor is going to be a bit trickier to visualize. You can, if you want, think it as a just many blocks put in 3D, or you can just think about putting many matrices one close to the other one. And as you increase the dimensions, it gets harder and harder to visualize what's happening. Okay. Now, let's see what I wrote here for rank 1. I wrote 3 comma. This means that this is a vector with 3 elements. Okay. Let's go to the rank 2 tensor. Now I wrote 2 comma 3. So the first number tells you how many elements are in the first dimension, and the first dimension is the one indicated by the arrow. Now it's quite a standard convention to start counting in the matrices in this direction. Okay, you'll find it in many places. So as you can see, the first dimension has 2 elements. The third dimension has 3 elements. This is a rank 3 tensor. So the first dimension has 3 elements, and is the depth indicated by the arrow. So as you see, we have 3 matrices stuck together, right? So that's where the 3 comes from. The second dimension is the one in this direction, right? As we saw for the rank 2 tensor. And this has 2 elements. And the third dimension has 4 elements. 1, 2, 3, 4. Is this clear? Yes. 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 And once this is the first dimension, and if you want to know what the second one is, just look at the previous diagram. Right. So this is the first by the arrow. So you have matrices stuck together. Once you choose what matrix you want to see, the other dimension, the second one, is the one in here. And the third one is the one in this direction. Okay. You can get a rank 4 tensor. A way to visualize this is like thinking about stacking many of these objects all together with a comma. So in this case, the first dimension is the one indicated by the arrow. So we have 3 of these things, these rank 3 tensors stuck together. And each of these rank 3 tensors is basically the same that was here, right? So 3, 2, 4, because it's the same object. And you can keep building up things. Now, you may think, why do we need to do all this complicated stuff, right? It's quite mind-blowing what we need. Now, the thing is that data, the data we're going to work with are represented as tensor. And that's why the library is called Tensorflow. You have kind of this idea of your data, it's in a big table, and it flows through your code, and it comes out as something else. Okay, so let's do a small exercise. Let's start from 42. 42 is a tensor, believe it or not. So what's the rank of the tensor? 0. Very good. Now I was trying to get 10. 0. That's right. Let's go to the parrot. This is a gray, a black and white image. And what do you think is the rank of this tensor? 1, 2, 3, 4. 3, 2. And here 3, 2. Okay. So I can represent this image by dividing it into pixels, right? This image is actually divided into pixels, and the pixels are in a grid, right? And every pixel has a value that might be from 0 to 1, might be from 0 to 255. It kind of depends on what convention you're using, right? So indeed, it's a matrix. Okay, so it's a rank 2 tensor. How about Leonardo DiCaprio? What's the rank of Leonardo DiCaprio, in your opinion? 3, 4, 3, 4, 5. So I heard something right. So it's RGB, probably. So if we look at each instant, right? So for instance, if you look at when DiCaprio has his glass here, right? We're going to have one matrix for the red color, right? It's going to tell us how much red there is in each pixel. Then we're going to have a matrix. for the blue color, and a matrix for the green color, okay? So this object itself is stacking three matrices together. So a matrix is a rank 2 tensor, and altogether this is going to be a rank 3 tensor, right? So that's fine. But then we have one of these things for each time, right? So this is time, the final time. So we're going to have one of these things for time 0, one of these things for time 1 of the gift, right? And blah, blah, blah. Time 0, time 1, and so on. So this is actually another dimension. Okay, so we are stacking many rank 3 tensors in time. So this is actually a rank 4 tensor. Okay, it's kind of a bit like this thing here, right? Where we were stacking matrices together. So this is actually the same thing. This is red, blue, and green, and we're putting all these things together, right? Now let's see. Once we know why we use tensors, let's try and see if we can make tensors. So let's go back, and we're almost done. Because I think we're slightly over time, like it's gonna be like 2-3 minutes over time. So first, let's import TensorFlow, which is the library that is used to work with tensors and to do machine learning stuff. And we do that by running this thing. As usual, I don't want to write TensorFlow because it's very long, so I'm going to import it as TF. Then I actually wrote already some code. So that's how we define. I was lying. Actually, should do something else first. So just give me 1 second. Okay, let's start by creating a rank 0 tensor, which is just a number. We do that by using the command. So rank 0 tensor. This is the name of my variable. It's completely arbitrary. It's equal to TF, which is TensorFlow.constant, and I write for. Okay, so constant means that I'm creating a constant tensor. So I run that, and maybe now I can make this thing. For the remaining things, I'm just gonna copy paste. It's gonna be quicker. So this is what we're getting. It's telling me that this object is actually a tensor. This is for the value in this tensor. The shape is sorry, if I pick the PowerPoint again. So the shape is this thing here in the bracket, okay? And of course, for a rank 0 tensor, there are no dimensions, so the shape is 0. Now I'm going to take all this thing and copy here. So this is creating a rank 1 tensor. So the way we do it is still use the same command, tf.constant, and then we're going to create one list with 3 elements, okay? Then this is going to be automatically converted into a vector. Indeed, if I read here, rank 1 tensor, it is a tensor of these elements. And the shape now, it has 1 dimension because it's rank 1. And so we have now an entry in the shape, which is 3. Okay. Finally, this is a rank 2 tensor. The way we do it is by taking many lists and stacking them into a list. Okay. So if you see here, I'm opening 2 brackets. So this is this big bracket contains lists of 2 elements each. Okay, if I put 3 elements in here, it will break the code. It will give me an error. And this is how it looks like: 1, 2, 3, 4, 5, 6. Right? It's kind of I could potentially even go on a new line here. Maybe it's easier to visualize what's happening. But yeah, in this case, the shape is 3 vertically, and it's 2 horizontally. Okay, so that makes sense. TensorFlow uses the same way of writing tensor I used earlier, but it was the opposite. But yes, this is what we're getting. Now, last thing I wanted to show you is that we can do things with tensors. Okay, so let's say we have this tensor is 1, 2, 3, 4. So it's rank 2 tensor. And we have this tensor, and which is 1, 1, 1, 1. A and B. Okay. So this command once creates a tensor of rank 2. So there are 2 entries, and each of the dimensions has 2 elements. So 2 elements and 2 elements. Okay. And it fills it with 1. So what happens if I sum A and B? So print A plus B. No surprise, again, another tensor. And the entries of this new tensor here are just obtained by summing element-wise these 2 tensors or matrices, right? Now, the interesting that happens when we're working with 2 dimensions is multiplication, right? You may think that multiplying 2 matrices gives you a classic, the matrix multiplication that we all hate, not the one with rows and columns, but instead it does an element-wise multiplication. So this is something that is important to keep in mind. So if I do A times B, so you can check that this is actually just doing this times this and this times this, right? If we want to do an actual matrix multiplication, we use the at symbol, which is going to be A at B. And you can check that this is actually the right result. Okay, so any questions? Anyone? Yes. Yes. So if you see this one, I tried to avoid this thing because I wanted them all to be float. And since 1, 2, and 3, and 4 are integers, Python would have automatically given it the value of integer. So what I did was specifying the type artificially. So the type is equal to float. Indeed, if I remove this, it's going to give me an error, and that's why I did it. So it's going to give me an error because I'm trying to add an integer tensor with a float tensor. Okay. So this is integer, this is float. Now, I said earlier that you can usually do these kind of things, adding integer and float in Python. And this is mostly true. However, in some case, it's good for the computer to know what's the type so that things can run more efficiently in its memory, right? And I believe that with TensorFlow, you need to specify the type correctly, and you cannot add integers and floats together. But they're kind of stored differently in the memory of the computer, right? So probably that's why it's not accepting this operation. So I'm going to just add the type dot. Another way, you can just add a dot at the end of all the numbers. Now it works. Okay. Other questions? Yeah. They're quite similar. Because the TensorFlow tensors are meant to be used with TensorFlow, right? So in my life, my coursework, I never use TensorFlow. I always use NumPy. But if you want to do machine learning, you can make your NumPy arrays and then convert them into tensors and then use them for your whatever your machine learning algorithm might do. But this is not just the type of array that Google developed to work for its stuff. I don't know the details, so they may offer something extra compared to NumPy, but I don't know about that.
Yeah, I mean, specifically, like, there's a lot of the functionality that you don't get with NumPy arrays. You do get with tensors, so because it's like its own class, they can do stuff like remembering the gradient, which is really important, like with machine learning, which you can't do with NumPy arrays. So it's kind of really essential that you do understand how to instantiate them and update the.
Yes. n-dimensional array and a tensor? Nothing. Speaking of computing, right? Then tensors can be other things in maths or in other subjects, but computation-wise, they kind of work the same way. But yeah, as we said, the TensorFlow tensors are meant to be used for machine learning purposes. So with TensorFlow, you make tensors. With TensorFlow, you make machine learning models, right? So they're kind of compatible with each other. Any other questions? Yes? Yes, that was very vast. So this multiplication with the asterisk is not matrix multiplication. It's element-wise multiplication. So you take the top left element and you multiply it with the top left element of the other matrix. Okay? What?
It's like a dot product. Element-wise.
Yeah, element-wise. I wouldn't call it dot product. It's element-wise. It's going to give you an error. Like if that's why I chose them both to have the same dimension, right? 2 by 2, because otherwise it would give an error. So this is the operator you use to do matrix multiplication, is the at, right? Any other questions? Yes? Is there a? I just heard, is there a defined operation for? 5. Divide. Yes, there is. I should have put that. But since it's element-wise, there's no problem with that. So divide operator, for instance, is A divided by B. And this is what you're going to get. I'm dividing by 1, so it's going to be the same thing. You're free to go, but I think there should be pizzas. Yes. So, yes, if you don't have any questions, then that's it. I hope it wasn't too slow for you, because you probably all knew all this stuff. But yeah, I'll see you on Saturday if you want to come for the workshop, and we're going to work on some data, import them, and plot them. Woo! Thank you. Thank you.
Oh, hey guys, there's pizzas here. We did promise you pizzas, so. Yeah.
To probably many lines, 2 lines.
All right.